Hello, this is Mr. McLeod, and I'm going to be doing a little demo on insertion sort. In this demo, I'm going to use this example 75498, and we'll be sorting left side first in ascending order. Insertion sort, of course, works regardless of which side you're sorting first and whether you're doing ascending or descending, but we're going to just do this as an example. So the idea behind insertion sort is that you're going to take each item in the unsorted portion, okay, and you're going to insert it into the sorted portion, where the sorted portion starts out as just the first element. So first, we're going to take the 5 and insert it into the sorted portion. Then we're going to take the 4 and insert it where it goes. And then we would take the 9 and insert it where it goes. And finally, we take the 8 and insert it where it goes. And when we're done with that, we will have the whole list sorted in order. Okay. So we could also say, just a reminder, this is index 0, 1, 2, 3, and 4. So that means essentially what we're doing here is first we're going to sort, we're going to insert the item at index 1. Then we're going to insert the item at index 2. Then the item at index 3. And finally, the item at index 4. So let's go ahead and do that. So we're inserting, okay, so here's the list, and we're inserting the item at index 1. And so what I'm going to do is store that value in a temporary variable. I'm going to call this K for key. Okay. And so the item at index 1 is 5. So that means this is the one that we're going to be inserting in the correct position. So since we want ascending order, all we need to do is ask ourselves at each index, starting at index 1, if the item to the left is larger than the key, then we write the item to the left, we shift it over to the index that we're at. Okay, so for example, the first question is, what goes at index 1? Is it going to be 7 or 5? Since 7 is larger, that needs to shift over, so we write a 7 there. Okay, notice that when I do that temporarily here, I don't actually have the 5 in the array. So if I hadn't saved it in a temporary variable, I would have lost it. But no problem, we did save it in a temporary variable, so we haven't lost it. Okay, so now we've dealt with that index. Now we need to deal with index 0. Okay, so we just decrease the index by 1, and we're deciding what goes here. Well, there's nothing to the left, so that means the 5 has to go there, and we're done. So now this section is sorted, and this is now the unsorted section, and we're ready to insert the item at index 2. And we just repeat this process. So the item at index 2, we save it in our variable 4. So K is 4 now. And I just need to rewrite the list real quick. And then starting at index 4, starting at index 2, I ask, is the 4 larger or the 7? So 7 is larger than 4, so I shift it over. And I've now written that index, and then I reduce the index that I'm looking at by 1. Now I'm looking at index 1. And the question is 5 larger than 4? Yes, it is. So I shift the 5 over. And then again, I've reached the last index. So therefore, the 4 has to go here. Okay, so when you're coding this, you want to be careful that you can't go out of bounds, right? You can't check to the left of this index at index 0, or you'd be out of bounds. So once you've reached that last index, then that's the place where you should insert it. Okay, so now these 3 have all been sorted, and the unsorted list is now just the 9 and the 8. And we're now on index 3. So let's rewrite the list out. Okay, so then at index 3, we store the value, which is 9. And then we decide what's going to go here. Okay, so at index 3, we're either going to put a 7 or a 9. The 7 is not larger than 9, so the 9 goes right back there. And we're done. We've inserted the 9 where it goes. Okay, so now these ones are now all sorted, and only the 8 is left in the unsorted section. So now I'm going to rewrite this list out. Okay, so this time we're inserting the item at index 4, store it in our variable, it's 8, and I decide first, is 9 greater than 8? Since it is, I write the 9 at index 4, and now I'm figuring out whether I should insert the 8 at index 3. 7 is not greater than 8, so therefore I do insert the 8 at index 3. And I've now sorted the whole thing. This is all sorted, and we're done. Okay, so to code this, we simply have to take the understanding that we got from this diagram and turn it into code. So I'm going to make a function public static void sort, and it's going to be an array of ints. Whoops, holy smokes. It's going to be an array of ints into an, okay, and we're going to call that ARR. Okay, and we've got 2 loops, right? So there's the outer loop, and the outer loop is the one that tells us which index are we going to be inserting, right? So we can see right here that the outer loop is going to go starting at 1. And notice this index, this list is length 5. So we did 4 iterations, okay? Because since the first item is always already sorted, right? It's a sorted list of 1. Then the other 4 are the ones that each need need to keep getting inserted. So it's always going to be one less than the number of items in the list. So therefore, we can just go from 1 to up to 1 less than the number of items in the list. So we would write that as for int, let's call it I equals 0, so it matches what we did here. Whoops, not 0. Notice we're starting at 1, right? From I equals 1, I'm going to just write this as less than or equal to. You could, of course, use less than or equal to, and that would affect what you put over here. But I'm going to just say we're going to go less than or equal to ARR dot length minus 1. So counting from 1 to 1 less than the length would be equivalent to like what we did here, 1, 2, 3, 4. Okay, then we're going to take each time, we're going to increase I by 1 so that we go 1, 2, 3, 4, that kind of thing. Okay, so then in the inner loop, remember that when we did this, each time we saved the thing that we were going to insert in a variable, right? We called it K here. So let's go ahead and call that K again. So we say int K equals, and remember that each time it was simply the item at index at the index that we were inserting. So since we're going, and our outer loop is representing that number 1, 2, 3, 4, right? The first time it's going to be 1, and then 2, and then 3, and then 4. Then that means we're going to be setting K to the item at index I in the array. Okay, so then now we just need to do the loop that actually finds the position to insert this item at. And while it's finding it, it's also shifting the other items to the right. So for this loop, we need to have a starting point. And my plan, you could do this with a for loop, or you could do it with a while loop. I'm going to actually use a while loop so that I'm going to declare the position where I'm going to insert the item. And then the while loop is going to keep shifting things over and decreasing the value of that variable as long as it hasn't reached the point where it should insert. And so that when the loop is done, that's the place where we will insert. So if we were to write this out kind of as pseudocode, we would say, and there's two things that we need to check for here, right? So while we need to make sure that we are not out of bounds, right? So while we haven't reached out of bounds, and the position, let's see, and we should shift then we're going to shift to the right and then decrease the position. So I should have written here that we're going to have a position variable declared, and we're going to decrease the position. Okay, and then once we've finished this loop, then that will guarantee that this loop will end once pause is the actual position that we should insert at. So then we should just set the item at pause to the key. Okay, so let's go ahead and turn this into real code. So first, okay, so we kind of have an understanding there of what we're doing. That's our plan. Let's go ahead and do it. So int pause, we need to declare our position counter, and it's going to start out at I. So basically, it's like what we did before, where first we decided whether to shift the next item over to where we started, and then shift the next item over to the next position, and so forth. Okay, so while, and if we want to make sure we're not going out of bounds, since we're planning to look to the left to see if we should shift it over, then as long as I is, as long as pause is greater than 0, then there is an item to the left, right? So as long as that's true, and so that way, if pause was 0, then we've now reached the far left side, and that's where we should just insert there, right? So the loop should end, because pause is now the value that should be, is now the index where we should insert. Okay, so while pause is greater than 0, and to check if we should shift, remember that we kept checking if the item to the left was greater than k, because if it was, that means k should go to the left of it, of that item, right? So that means that item needs to be shifted to the right. So for example, if it was like 8 and 3, if 8 is greater than 3, and actually just to be clear, k is 3, right? So we're figuring out what goes here, right? If 8 is greater than 3, that means we need to put the 8 here, because that means 3 goes, whoops, that means 3 should be inserted somewhere to the left of 8, right? And it might be here, or it might be further left, depending on what the next one is, right? Like maybe the next one is 7, right? In which case, again, we still wouldn't put the 3 there. Then we'd put the 7 there, right? And so forth. Okay, so that means the correct thing to check here would be as long as the item at pause -1, okay, so the item to the left of pause is greater than k, then that means we should shift, right? So this is, we could say, we wanted to write in words what we're doing here. This is the item to left is greater than k. Okay, so as long as that's true, then we need to shift the item to the right, which really what that means is it means we're going to write the item that is to the left of pause at pause, right? So the item at pause should be overwritten to be the item to the left of pause, pause -1. Okay, so basically we're shifting pause, should say shifting item at pause -1 to the right. Okay, and then we also need to decrease pause so that we look at the next position. So pause minus minus is going to look at the next position over. And if we repeat this process, then eventually when this loop is done, pause will be the place where we should insert K. So insert K means basically write K to that position. So after this, we just need to say ARR pause should equal K. Close the for loop, close the function, and we're good. Okay. So we could actually demonstrate that this works if we just stepped through the code and we just did what we did up here with our understanding of it before, except this time we're going to actually step through the code and confirm that it does what we're expecting it to do. Okay, so we start out with 5, 7, 5, 4, 9, 8. Okay, so if we did this right, then I should start out as 1. Check. In the first iteration, I is 1. And then we're going to set K to be ARR I. Well, that's 5. So far, so good. K is 5. And then we're going to set pause to I. So to indicate where pause is, I'm just going to do a little underline. And so right now, pause is I, which is 1. So far, so good. And then we check to see, is pause greater than 0? Yes, because 1 is greater than 0. And then is pause, is the item at pause minus 1 greater than K? So pause minus 1 would be this, would be 0, right? So the item at 0, which is 7, is that greater than 5? And it is. Therefore, we set the item at pause, which is right here, to the item at pause minus 1, the item to the left, which is 7. So 7 gets written here. And then pause decreases by 1. So I'm just going to move this. So now pause is here. And then the loop repeats. And here it says, we do the check again. Is pause greater than 0? No, because now pause is 0. Therefore, the loop ends. And it says, then we're going to set the item at pause to K. So we set the item right there to 5, because that's what K is. And boom, these first two are now sorted. And so far, so good. That has worked. This is now the unsorted portion. And we're ready for the next iteration. So then it goes back up here to I++. And so now I is 2. That's still less than or equal to the length minus 1, which is 4, right? So it does another iteration. And this time K gets set to ARRI, where I is 2. So that's going to be the 4, right? Okay, so pause also gets set to 4. And just before we start this, I should actually write out the list. Let's see here. Actually, I feel like I wrote this one a little bit too big. I'll just make sure I write this one small enough. Okay. So I don't want to get out of sync with this. Okay, so we got 5, 7, 4, 9, 8. And here's where pause is. Okay, so pause is the item at index sorry, pause is I at first, okay? And is that greater than 0? It is. So then we check also is ARR pause minus 1, which is 7. Is that greater than K, which is 4? 7 is greater than 4. So therefore, we're going to set the item at pause to the item at pause minus 1. So that's the 7. And there we go. Okay. And then pause minus minus moves pause to here. So now we're at index 1. And we go back to the top of the loop again. Is pause greater than 0? And it is. And pause minus 1 is right there. Whoops. Pause minus 1. The item at that index is 5. And the question is that greater than 4? And it is greater than 4. Therefore, we set the item at pause to 5, right? Because the item at pause minus 1 is 5. And then pause minus minus. So now pause is here. Oops. Okay. And it goes back up to check the while loop again. Is pause greater than 0? This time it is not. Therefore, the loop ends and ARR pause equals K. So we set this item to K, which is 4. And again, so far looks good. So now these ones are sorted, and we're left with 9 and 8 in the unsorted. Okay, and then it goes back up to the top of the loop again, and it does I++, right? So it's going back here again, I++. Yeah, that's how I can do that. And then again, we're at I equals 3, and that's still less than or equal to the length. So we do, okay, K equals ARR 3, which is the 9. That's what we wrote right here. So far, so good. And then pause equals I. So pause is going to be 3. And let me write this list out again so that we can work through it. Okay, so pause is now at that index 3. And that's greater than 0. And pause minus 1, the 7, is that greater than K, which is 9. So this time 7 is not greater than 9. Therefore, the loop ends right away. Okay, which means we're going to set the item at index 3, right, at pause, to K, which is 9, and it's already 9, so it's okay. It just overwrites it again and writes 9 again, and we're done with that. Now these ones are in order, and now only the 8 is in the unsorted section. All right, and so then let me just write this one out. Okay, so then it's going to go back up here, and now, whoops, and now I is going to be 4, which is still less than or equal to length, length minus 1, because length was 5, so 4 is equal to that. Okay, and so we're going to say K equals ARR 4, which is 8. Looks good. Okay, and then pause is going to equal 4. So that means pause is right here. And while pause is greater than 0, it is, and pause minus 1, which is 9, Is that greater than k, which is 8? Yes, 9 is greater than 8. Therefore, we write ARR pos is going to be ARR pos minus 1, which is 9. So the 9 gets written there. And pos minus minus shifts, oh, whoops, erased too much. Okay, shifts this over to here. And the loop check happens again. Is it greater than 0? Yes. Is ARR, see, actually, I should get a different color here. Let me get red here. Is ARR pos minus 1? So that's the 7. Is that greater than k, which is 8? And this time 7 is not greater than 8. So the loop ends because this is false. And therefore, it's going to write ARR pos equals k. So it's going to write the 8 right here at index pos, which is the 3. Okay, so at that point, the last thing, I guess we go up here and I increases to 5, and that is no longer less than or equal to the length minus 1. So therefore, our whole outer loop is done, and our algorithm worked perfectly. Okay, hope you enjoyed this, and hopefully this was helpful in you understanding insertion sort. And goodbye.